Okay, so let's get to 2004 past question. This was question number 43, and we are still dealing with the logarithm with equation. So it says if log 6, let's take it, if 6 log 2 base x minus 3 log 3 base x is equal to 3 log 0.2 base 5, find x. Alright, so that's the question. Please pause the video. As usual, try to solve it. Attempt to solve it, please. Pause the video. We compare our answer. Okay, so let's start to solve this. And the first thing we're going to do will be for us to rewrite it. So rewriting it, we're going to have it, the first part, 6 log 2 base x. We're going to rewrite it, and that will give us, this 6 here is coming to these 2 to become its power. So this will become log 2 raised to the power of 6. Okay, and the base is going to remain. That was x. Okay, and this, of course, let's have our subtraction, and the same thing will be applied to the next year. So we're gonna have here still as log, have here as log, and we know that the 3 behind is gonna cross over as well. It's gonna cross over, it will become the power of this other 3. So yeah, and then that's kind of big for us. Okay, let's work with that. And then that will be power 3, and we have here the base x remains, and of course it will be equal to everything that we have here, and that will be the same thing is going to apply here. You understand? This 3 that was behind is still going to come over here, and it will become the power of this. But now this 0.2, we need to work on this 0.2, so we don't have it as a decimal, and 0.2 is the same thing as saying 2 all over 10, because if we divide 2 by 10 by moving the decimal points one place to the back, it's going to give us 0.2. Now 0.2 also is the same thing as saying 2 cancel itself here one time, and then 2 comes into 10 5 times. So 0.2 is the same thing as saying 1 all over 5. Great. And 1 all over 5 is the same thing as saying 5 raised to the power of minus 1. Good. 5 raised to the power of minus 1. So we can use this. We can use this when as we are writing. All right. So we're gonna use that. And now let's have our log first here. Let's have our log first here. Log. And in the place of 0.2, what do we have now? 0.2, we're going to replace it with 5 raised to the power of minus 1. And remember, we have a power here. So everything here, let's bracket everything here, because it's going to be that bracket, everything there raised to the power of 3. All right, so it's going to affect only the power, so we can just say, yeah, the power here times 3. Yeah, it's going to be only the power times 3, and the base is 5, so 5 comes here. Are you making progress? Yes, we are making progress. So we can continue. And continuing, our left hand side, we have something that is common, log x and log x, so we can pull it out and rewrite it. We can pull it out to rewrite. So, and then log x, so we have here log x, and everything about this, the ones that we have subtraction in indices, what are we going to do? Anything subtraction, we will divide. We're going to divide. So, and for us to divide, that will be 2 here that we have to raise to the power 6, that we have here 2 raised to the power Okay, that's not what I'm looking for. Let's have something better. Okay, 2 raised to the power of 6. We're going to divide it with 3 raised to the power of 3, because now this subtraction has become the division here. All right, and it will all be equal to, all right, let's work this out now. Okay, and working that out, let's pull down our log first. Okay, let's pull down our log first, and the next thing we're going to do will be for us to work on this power. So it is log 5. It is log 5. Now minus 1 here times 3, that will make it minus 3. Log 5 minus 3, and of course the base is still base 5. Cool, we're making progress, are we not? Yes, we are. We're making progress. All right, so let's work on this still left hand side, and working on the left hand side we can have it as log x. Let's have work on the left hand side, and then that will be log x. Okay, all right, log x. And now look at something. We need to have everything, what we need to have the numerator and the denominator to the same power, and to have it to the same power, we will do this. We'll do this now. Let's just have the same. So let's break it down, not really to the same power, but let's break it down. So we have here as 2 raised to the power of 2 first, all over. I don't want to use that. Okay, we have here as 2 raised to the power of 2 first. Now all over 3. Now everything now will be in the power of 3. Yes, if everything is going to be in the power of 3 to make it the same. Yeah, everything now becomes in the power of 3. Good, because 2 raised to the power of 2 times 3 is same thing as saying 2 raised to the power of 6. Okay, and then 3 raised to the power of 3 is the same thing. 3 times 3 raised to the power of 3 here is just the same thing here. Right, let's have the right hand side down, and then having the right hand side, something's going to happen here. Look at this. The law of logarithm is going to come in here, right? This power is going to come right behind this. Okay, all right, so obeying that law of logarithm, so we're going to now have here as minus. Okay, so we have this side now, everything now will be equal to there's something that I want you to see. Okay, so log 5 base 5. Remember, any log to a number that has the same base is 1. All right, so when this minus 3 cross over here, this minus 3 is going to cross over here, and that will be minus 3, and that should be minus 3 times 1. So minus 3 times 1 is the same thing as minus 3. Okay, so we proceed, and something is going to happen now, because we don't want this log here, and because we don't want this log, and this log has a base of x, so everything now you're going to have this. What you're going to have will be 2. Remember, okay, now let's add this place. Everything here was raised to the power of 3. All right, so we're going to have here 2 raised to the power of 2. Okay, all over 3. Let me, and everything raised to the power of 3 here. So will be now equal to, now I want you to observe something, because you don't want to write it with this log. You want to ignore this log, and this is log base x. Now that base is now equals to that base. Sorry, let's use color for numbers. Equals to that base. Okay, that x, and something's going to happen. This minus 3 here happened to be the power. That's minus 3. Yeah, that was the power. All right, so we're making progress. And so what we're going to do now is, since the base are not the same, and the powers. We want to make the powers to be the same. When the powers are the same, we can equate the base. So to make the power the same, we're going to rewrite this, the whole of this, because we want to change this power 3 to minus power 3, to minus power 3. Okay, to the power of minus 3, yeah, to the power of minus 3. That's what we're going to do. And for us to do that, this is what is going to happen. To have that as minus 3, everything, the denominator here will move to become the numerator, and the numerator here will move to become the denominator. Now, can we have that? All right, so it's easy for us to have that in base of negative now. So 3 for the denominator, so in it 3 will now move to become the numerator, so it now becomes 3. Good. The numerator becomes the denominator as 2 raised to the power of 2. Good. And the power will still remain, and the power that is remaining now is not minus, it's not 3, no, because we have inverted it. The power that will remain now will be, the power that we are going to have now will be minus 3. That will be the power. Good. Minus 3. All right, let's have it. All right, and of course equal to what we have here, and that is minus, that it will be x raised to the power of minus 3. Okay, so finishing this up now, observe something. The powers now are the same. We have minus 3 here, and also we have minus 3 here, so the powers are the same. So since the powers are the same, we can equate the base. We can equate the base. All right, all this base, that's what we can do to the base. So let us do that right now, and that will become 3. All right, 3 over 2 raised to the power of 2. Okay, that will be equal to, of course we have here is x. All right, that will be equal to x. Okay, and solving that out, we still have it as 3, and 2 raised to the power of 2 is what? Is 4, and then equal to x. All right, let's do this. And of course that 3 over 4 equal to x is the same thing as saying x is equal to 3 over 4, right? Yeah, so that's it. Let's check our option. Let's get to our option and see if we have the answer, any option as 3 over 4 as our x. All right, so option C, and that's the correct option. All right, so that was simple. This was the question that we were given. If 6 log 2 base x minus 3 log 3 base x equals to 3 log 0.2 base 5, find x. So simple. What we needed to do was for us to rewrite it and then obeying the simple law of logarithm, and then the 6 that we had here became the power to these 2, the 3 that we had here became the power to this other 3, and something happened to 0.2. We have to change 0.2 to fraction first, and 0.2 is the same thing as saying 2 over 4. We did it here, and then we went ahead to divide. 2 cancel itself, 1 comes into 10, 5, 1 over 5, and 1 over 5 is the same thing as saying 5 raised to the power of minus 1. So we replaced our 0.2 here with 5 raised to the power of minus 1. That's what we had here. All right, and then we observed something to this other side, that log x is common. Log base x is common, so we pull out one of it, log base x, and where we have as minus, that's 2 raised to the power of 6. It will not change to division, so it now became 2 raised to the power of 6 divided by 3 raised to the power of 4, and then we now had this one. At first, remember that initially this 3 here, this 3 came over and it became the power, so the new power now will now be minus 3 because we have replaced our 0.2 with 5 raised to the power minus 1. Good. Now we needed to break it down so that we can have a common power. We needed to break it down. So for 2 raised to the power 6, we now have it as 2 raised to the power 2 to replace 2 raised to the power 6, and then for the numerator and denominator to share the same power, and that's this power 3. Now we came to this other side, and log 5 base 5 is 1. when this minus 3 as a power comes over here to now become minus 3 times 1, that gave us minus 3. All right, and we needed to pull out this log, and for us to pull out this log we need to write it as indices, and writing it as indices is just for us, we brought this one down equal to this log base x became the base here equals to x, and then of course this became the power minus 3. So we needed to have minus 3 here and minus 3 here as the power, and for us to do that, introducing minus 3 here, it was 3, so we want to have minus 3, so it will need us to invert, and denominator become numerator become denominator. We did that and the power became minus 3. Now we observed something, that both have the same power. Having the same power means we can equate what we have at the base, and now became 3 all over 2 raised to power 2 equals to x, and solving 2 raised to power 2 is 4, so 3 over 4 is equal to x. It's the same thing as saying x is equal to 3 over 4, and option C was the option. All right, so that will be it's going to end here for logarithm, and then we're going to see you as we get to the next subtopic. All right, bye-bye.